The Sun has just released one of the most powerful solar storms in decades. Every satellite in its path trembled, but one object did not. A traveler from beyond the stars called 3I Atlas. It took a direct hit from a plasma blast hot enough to melt steel, yet it didn't break apart, didn't change its course, and didn't lose its light. Its reaction has challenged everything we thought we knew about physics and astronomy. What is this object really made of? How can something from outside our solar system survive the fury of the Sun itself? This video may not give you all the answers, but it will help you understand the strange paradox surrounding 3I Atlas. On October 27, 2025, the Sun erupted with a force that scientists hadn't seen in decades. A massive coronal mass ejection, or CME, burst from its surface and raced through space at more than 3,000 kilometers per second. For most spacecraft, that kind of blast means the end. Fried circuits, melted panels, and total silence. But this time, the CME was heading towards something no one expected to survive. The interstellar traveler known as 3I Atlas. The object was at its closest point to the Sun, a stage called perihelion, where temperatures can soar to millions of degrees Celsius. Even the strongest man-made metals would have vaporized, yet 3I Atlas was about to face the full fury of the Sun. Telescopes from NASA, ESA, and the Russian Academy of Sciences locked onto the event, expecting to see a brilliant flash the moment the object broke apart. Instead, they saw something else. Silence. There was no sudden burst of light, no trail of debris, and no sign of disintegration. Every sensor registered the same impossible result. The object remained intact, still moving along the same path as if nothing had happened. Radar data confirmed it. The change in trajectory was less than 1/10,000th of a degree. To scientists who study celestial dynamics, that margin was almost supernatural precision. Even the slightest imbalance in heat or momentum should have sent the object spinning wildly off course, yet it continued its steady orbit like a machine following a perfect script. For context, other comets have not been so lucky. In 2011, Comet Lovejoy was torn apart by a similar solar eruption, leaving behind only a fading tail of gas and dust. Years earlier, Comet Encke lost nearly a third of its mass after crossing the Sun's magnetic field, its orbit permanently altered. Compared to them, 3I Atlas was an anomaly, a body that refused to behave like any comet or asteroid ever seen. It didn't flare up, it didn't fragment, it simply endured. That endurance turned a routine observation into one of the biggest mysteries in modern astronomy. How could a small interstellar object withstand a direct plasma strike powerful enough to destroy a satellite in seconds? The answer wasn't in its size, it was in its nature. Something about its composition or structure allowed it to resist forces that no natural body should survive. This event marked a turning point. For the third time in human history, a visitor from beyond our solar system had crossed our path, joining the short list of interstellar travelers that included Oumuamua in 2017 and Borisov in 2019. But unlike them, 3I Atlas didn't just pass through. It challenged the very limits of what we think matter can endure. In the control rooms of observatories around the world, scientists were stunned into silence. Every instrument agreed on one thing: something impossible had just happened, and it happened in plain sight. If the Sun couldn't destroy it, then what could? And more importantly, what kind of object could survive the most violent force in our solar system? The next part of this story begins right after the impact, when researchers realized that even the aftermath of the storm didn't make sense. After the solar storm hit, every major observatory expected chaos. They waited for the readings to spike, for fragments to scatter across space, for the light of 3I Atlas to fade away. Instead, the data came back calm, almost too calm. The object didn't explode or even flicker. What the scientists saw was not a dead comet, but one that seemed almost indifferent to the sun's most violent assault. Russian, Japanese, and European telescopes all confirmed the same result. 3I Atlas had survived untouched, though something strange had changed in the light it reflected. Its optical signal grew weaker, as if the object had dimmed itself. At first, researchers thought the plasma cloud might have interfered with the readings, scattering light in unpredictable ways. But as the hours passed, it became clear this was not interference. It was part of the object's behavior. Some scientists suggested that 3I Atlas could be absorbing energy rather than reflecting it. Others believed that the plasma storm had coated the surface in ionized dust, forming a temporary shield. But even these explanations didn't fit perfectly, because any ordinary comet made of ice and rock would have evaporated under that kind of pressure. To test the theories, simulations were run using the same intensity of plasma that struck the object. Each model ended the same way: destruction. A normal comet, made of frozen gases and silicate dust, would have completely vaporized within minutes. No combination of known materials could have survived those temperatures. So, what made 3I Atlas different? A new hypothesis began to circulate among physicists at the Moscow Institute of Space Research. They proposed that the object's core might be far denser than anything natural, perhaps a compound similar to nickel-carbon alloy. Such material, if real, could withstand over 10 times the stress limit of typical cosmic rock. It would not crack, melt, or deform easily, even under the violent heat of a solar eruption. If that was true, it meant the interior of 3I Atlas was not a fragile cluster of ice and dust like most comets, but a solid metallic heart forged under unimaginable pressure. This theory unsettled scientists because it hinted at something beyond random formation. Where could such dense composite matter come from? Was it the result of an ancient collision in another star system, or something more deliberate? Some began to describe it as a dense composite body, a term used for objects that show mechanical strength not explained by known cosmic chemistry. To many, it sounded like the line between natural and artificial was starting to blur. NASA and ESA stayed quiet, calling for more data before making statements, but the silence only fueled speculation. A few researchers even compared the object's resilience to engineered alloys used in spacecraft hulls, materials designed to survive both radiation and extreme heat. Still, no one could prove that 3I Atlas was anything other than an extraordinary anomaly. For now, it remained the most durable object ever observed moving through the solar system. The question scientists now faced was not whether it had survived, but how. What hidden power or structure allowed it to take a hit strong enough to destroy satellites and remain untouched? Before the solar storm ever reached it, 3I Atlas had already been acting like no comet anyone had ever seen. Months earlier, astronomers noticed a strange chemical signature coming from the object while it was still 4 times farther from the Sun than Earth. At that distance, everything should have been frozen solid, completely inactive. Yet 3I Atlas was releasing vapor. Not just any vapor, but glowing nickel gas. Nickel normally turns to gas only at temperatures above 2,900 degrees Celsius. Where 3I Atlas was, the surface temperature should have been barely 100 degrees. That's a difference of nearly 3,000 degrees, a physical impossibility by every model of comet chemistry. Even more mysterious, there was no trace of iron. Nickel and iron are twins in space. They are born together inside stars and found side by side in every meteorite, asteroid, or comet ever studied. Finding nickel without iron was like finding smoke without fire. It broke the basic rules of how metals behave in the cosmos. Two researchers, Rohan Rajagopalan and Daryl Seligman from the University of Chicago were among the first to analyze the data. They proposed that this could be a new kind of chemical decoupling, where certain compounds separate under unusual radiation. Their hypothesis was that the nickel might be trapped inside exotic molecules, perhaps nickel carbonyl or nickel cyanide, that break apart easily under ultraviolet light. When the molecules split, they would release pure nickel vapor into space. On Earth, both of those compounds are used in industrial metallurgy. They are stable only in controlled environments and are rarely found naturally. If 3I Atlas really contained them, it would mean the object was made of processed material. Metal that had already gone through some kind of refining event. That alone was enough to shake the scientific community. Data from the James Webb Space Telescope and the Very Large Telescope in Chile added more confusion. They confirmed the presence of nickel gas, but no one could find a thermal process to explain how it formed, and the readings looked more like something that had been manufactured than something born in space dust. It was as if the object's materials had been purified long before it entered our solar system. Some scientists speculated that 3I Atlas might have passed through an ancient collision, a supernova remnant, or a high-energy environment that changed its chemistry. Others began to wonder if it had been built that way, a relic of technology lost to time. The mystery of its composition deepened after the solar storm. If the core was indeed dense and metallic, it could explain how it survived the blast. But it didn't explain where such a material could come from or how it formed billions of years ago. Perhaps the answer lies in the heart of 3I Atlas, where those impossible metals are locked in place, waiting to tell their story. And if that's true, it raises a haunting question. Was this strength born from nature, or was it designed? Because when scientists next observed the object, what they saw suggested that something inside it was not only strong, but moving with purpose. By September 2025, just weeks before the solar storm, 3I Atlas began to display a phenomenon that defied every rule of celestial mechanics. Telescopes at the Nordic Optical Observatory in the Canary Islands detected a strange anti-tail, a glowing stream of dust and gas pointing directly toward the sun. Normally, a comet's tail always points away from the sun, pushed by solar radiation and the solar wind. An anti-tail can appear under rare conditions when Earth's viewing angle lines up perfectly with a comet's orbital plane, making dust ejected earlier look like it is pointing backward. But what happened with 3I Atlas wasn't a trick of perspective. Over 2 days, the anti-tail didn't fade. It rotated. It slowly turned to align perfectly with the direction of solar radiation, transforming into a normal tail again. The movement wasn't chaotic or random. It followed a smooth, symmetrical curve that seemed almost calculated, as if the object was correcting its own position. For scientists, that kind of coordinated shift was not something comets were supposed to do. Most comets rotate irregularly, releasing gas in unpredictable bursts that cause wobbling and uneven movement. 3I Atlas, on the other hand, behaved like a spacecraft adjusting its orientation with precision. When the data reached Harvard, astrophysicist Dr. Avi Loeb analyzed the event and proposed a controversial idea. He described the motion as possibly being caused by controlled jet emission, meaning that gas vents on the comet's surface might be firing in specific directions to change its attitude, the way small thrusters do on satellites. Loeb didn't claim it was artificial, but he did argue that the behavior deserved serious scientific attention. His statement divided the community overnight. Half of the experts argued it was a geometric illusion caused by the comet's tilted orbit and the angle of sunlight. The other half admitted that the symmetry was too perfect to dismiss. Even comets known for strange outgassing, like Encke or Halley, had never shown this level of balance or timing. Meanwhile, international research groups began comparing 3I Atlas's motion to another strange case, Oumuamua, the first interstellar object ever found. Back in 2017, it too showed small but unexplained changes in speed and direction, as if responding to sunlight or even observation itself. Now, scientists were asking if 3I Atlas might be doing the same. Some data suggested that each time telescopes focused on it for extended periods, its brightness fluctuated in rhythmic pulses. It was as if the object reacted to being watched. Of course, that could be coincidence, but it added to the growing list of mysteries that no simple comet theory could fully explain. To skeptics, it was all physics: light, heat, gas pressure, and viewing geometry combining to fool the eye. But to others, it hinted at intelligence, or at least intention. If the anti-tail was indeed part of a guided motion, it meant 3I Atlas was capable of self-adjustment, something that natural bodies aren't designed to do. Whether it was reacting to the sun or to us, no one could tell. What was clear, however, was that it had control. And if it could control its direction, the next question was obvious. Where exactly was it going? The answer would come from its flight path, a journey so precise that it seemed written by hand. When the solar storm ended, scientists expected at least some visible damage on 3I Atlas, a change in speed, a fragment trail, or maybe a distortion in its orbit, but none of that happened. Days after the plasma strike, the Mars Reconnaissance Orbiter and the Solar and Heliospheric Observatory, SOHO, both confirmed the same incredible result. 3I Atlas remained exactly where it was predicted to be, following its original path down to the second. There was no drift in velocity, no wobble in its rotation, and no sign that the object had been physically altered. To orbital engineers, this level of precision was almost impossible. Every natural body in space responds to forces, gravity, heat, or radiation, that slightly change its motion over time. But 3I Atlas moved as if it were under perfect control, like a satellite guided by invisible hands. Even more puzzling were the readings from Mars. The orbiter's high-resolution cameras, which had captured close-up images from just 12 miles away, were expected to reveal the comet's surface in detail. Yet when the data reached NASA servers, public access to the files was quietly locked. A message appeared saying the images were under internal review. That phrase sparked an immediate wave of speculation across the scientific community. Why would NASA restrict images of a natural object? Some insiders hinted that the photos showed an unusual texture on the surface, something too reflective or too uniform to match normal comet dust. Others whispered about strange geometric patterns, like crystalline plates or metallic reflections. Nothing was confirmed, but the mystery grew. Spectroscopic analysis of the light from 3I Atlas revealed an unexpected property. Its surface appeared to scatter heat in a controlled way, as if it had a chemical coating that resisted plasma damage. This discovery led engineers at the International Asteroid Warning Network (IAWN) to consider the object as a natural test case for future spacecraft design. If humans could understand how it survived, we might learn how to build ships capable of traveling close to the sun without melting. One European Space Agency engineer even remarked that 3I Atlas behaved like a heat-proof vessel, a term normally used for spacecraft, not comets. The idea was both thrilling and disturbing. Could nature itself create something so close to technology? While most scientists held back from making conclusions, the silence from major space agencies only made the world more curious. Even professional astronomers began to say privately that 3I Atlas didn't behave like a visitor anymore. It behaved like something on a mission. Its trajectory told the same story. The path it followed was mathematically perfect, cutting through the inner solar system in a pattern that touched almost every major planet. From Jupiter to Venus, then to Mars, its route mirrored the kind of grand tour NASA once planned for robotic explorers. Such accuracy could not be random. It was either an extraordinary coincidence or evidence that the object had some kind of internal guidance. As telescopes continued tracking it, one question grew louder among researchers. If this object was able to hold its course and survive the impossible, was it truly a comet, or was it something built with purpose? The search for that answer would lead directly to one of the most controversial voices in astronomy, a man who believed the truth might be much closer to what many feared. After the shock of the solar storm faded, the debate about 3I Atlas only grew louder. To some scientists, it was the most resilient natural object ever discovered. To others, it was something far stranger, something that might not be natural at all. Among those voices stood Dr. Avi Loeb, a Harvard astrophysicist known for challenging the boundaries of traditional astronomy. He had already caused global controversy in 2018 when he suggested that Oumuamua, the first interstellar visitor ever recorded, could have been a light sail, a probe powered by sunlight and built by an advanced civilization. Now, Loeb was turning his attention to 3I Atlas, and his questions were shaking the field once again. In a recent panel discussion, he noted that 3I Atlas showed several traits that match the profile of a controlled device rather than a drifting rock. First was its stable velocity. Even after being hit by a coronal mass ejection powerful enough to melt most spacecraft, the object maintained its speed perfectly. There was no deceleration, no spin irregularity, and no evidence of mass loss. Loeb called that statistical defiance, the kind of precision that requires either design or luck beyond probability. The second clue was its path, the so-called grand tour trajectory. 3I Atlas passed remarkably close to Jupiter, Venus, and Mars, tracing a course that resembled the planned routes of robotic probes designed to study gravitational fields. In Loeb's words, the orbit looked more like a survey mission than a random pass. Then there was the symmetry of its outgassing. Comets release gas unevenly, which causes unpredictable thrusts that make their motion chaotic. 3I Atlas, however, expelled material in a near-perfect balance, keeping its motion steady. For Loeb, that balance was not an accident. It was a system maintaining control. While most of the scientific community dismissed his claims as speculative, Loeb argued that the goal of science is not to confirm what we already believe, but to test what we fear to ask. He reminded listeners that the Milky Way holds over 100 billion planets, and the odds that Earth alone developed intelligence are impossibly small. If we see an object behaving in ways no natural body should, he said, we have a responsibility to consider every explanation, including the artificial one. Supporters of Loeb's Galileo project agreed, saying that humanity's fear of ridicule often prevents discovery. They pointed out that every major breakthrough in science began with someone questioning the impossible. Still, critics countered that extraordinary claims require extraordinary evidence. They warned that too much focus on alien theories could distract from real physics still waiting to be understood. Yet even the skeptics admitted that 3I Atlas had crossed a threshold. It had survived a solar storm that should have vaporized it, moved with unnatural precision, and reflected light in ways that hinted at technology or at least intelligence. Whether by coincidence or design, it was rewriting the rules of what space objects could be, and that led to an even more unsettling idea. What if 3I Atlas was not a visitor at all, but a messenger? If its survival and path were both intentional, then perhaps it was carrying something far greater than data or minerals. In the end, 3I Atlas became more than just a comet. it became a symbol of how little we truly understand about the universe. Its survival through the solar storm proved that matter from beyond our solar system can possess properties we have never encountered. To many scientists, this was the birth of a new category, the interstellar composite, a class of objects forged in extreme environments, colder and older than anything around our sun. If that is true, then 3I Atlas carries within it the record of another world, a frozen time capsule drifting between stars for billions of years. It may have crossed galaxies, collecting radiation, particles, and information about the places it passed, like a natural probe created by the universe itself. This idea connects to the ancient theory of panspermia, the belief that life can spread across star systems through comets and debris. If such objects can survive plasma storms and interstellar travel, then the seeds of life might already be moving from one star to another. Some astronomers now describe 3I Atlas as a messenger of chemistry, carrying the DNA of its home system, a fragment of cosmic memory written in gas and metal. Perhaps it is not artificial, but purposeful in its own way, showing how the universe preserves knowledge through the endurance of its creations. And as it drifts back into the dark, one question remains. Was 3I Atlas simply a relic of nature's power, or a signal sent across time, waiting for someone like us to finally notice? For now, 3I Atlas is fading into the darkness, carrying with it the secrets it refused to give away. It came from another star system, faced the full power of our sun, and survived without a single scar. In doing so, it forced humanity to confront its limits, not just in science, but in imagination. Whether 3I Atlas is a natural relic or something far greater, it has already changed how we see the universe. It reminded us that the unknown is not empty, it's alive, waiting to be understood. And as it drifts beyond our reach once more, one thought lingers. If this was only one visitor among billions, what else is out there, quietly watching us from the stars?